Hello folks, hope you're all doing okay. This is Mr. Havenland here, broadcasting from my bedroom. I'm going to try and go through any questions you get really stuck with. You're welcome to request any via messages and show my homework. This one was quite a tricky one on the last bit of work, so I'll go through this. It was question 10. So we've got two histograms here showing the distributions of heights of young trees in two different woods. Two very different histograms. Explain why you cannot compare the distributions. If you remember back, I think it was to part of chapter 2, we can only compare histograms if they have the same class intervals, which if you look closely these don't, and if they have the same frequency density scale. Now this one uses frequency density and this one actually uses frequency, so they definitely don't have the same frequency density scale. Okay, so we're just going to use those reasons. So I'll write that down. Oops. Note that I'm using class intervals here rather than class widths, because it's possible that you could have two histograms that have the same class widths. In other words, you know, it has the same number of bars that have the same widths, but the intervals start and end at different points. There's no doubt about it, question B is just a really tricky question, so it's no wonder a lot of you struggled on this one. It says, for each histogram, calculate an estimate of the average height and measure of spread. Now remember, we can only use certain measures of spread with certain averages here, so we've only really got two choices. We can either use the mean as our type of average, and therefore the measure of spread we would use with this is the standard deviation. Or we could use the median, and the measure of spread we would use with this is either the range or interquartile range. Now, neither of these are going to be easy to find, the mean or the median. I'd say probably the median would be slightly easier, so let's go with that one. Right, so when you're finding the median from a histogram, we need to find the middle bit of data. We need to find out how many bits of data there are, therefore. So in Wood A, fortunately they've just used frequency, so we can just look at the frequencies. There are 8 trees in this bar here. There are 30 trees in the second bar. There are 55 trees in the third bar. 47 trees in the fourth bar, and 15 trees in the fifth bar. So altogether, the calculator here, that is 155 trees. So the middle one is the 77.5th one. Now I know that doesn't exist, but that means it's between the 77th and 78th tree. So we've got to find where they are. Is the 77th in here? No. Okay, if you start thinking about cumulative frequency now, we're going to accumulate these. If we add in the next set of trees, is the 77th in there? No, we've only seen 38 trees so far. Okay, if we add on the next 55 though, that would definitely take us above 77, so it must be in there, but whereabouts in there? Well, we're after the 77.5th tree. Up until this point we'd seen 38, so if I take away 38 from 77.5, that will tell me how far into that next group it is. So that's 39.5. So it's 39.5 into the 55 in that next group. So 39.5, 55 out of 55, that's the fraction of the way between 150 and 160 that the median is. Now that's a class width of 10. So I've got to work out what that is, and then don't forget you've got to add back on to the lower bound of that group, which is 155. So this is linear interpolation that we're doing here. Okay, and that gives us 157.18 to 2 decimal places. Okay, now we've got to do that for histogram B as well. So the problem is with this one, we've not really given any of these numbers. Not detailed enough anyway. So the number of trees in this first bar, remember we've got frequency density here, and frequency is equal to frequency density times class width. So in this first bar, the frequency is 0.5 times 10, so 5. Easy enough, that one. The next one, though, is the issue. It's got a class width of 5, that's easy enough to see. But what is its frequency density? It's not actually 0.6, because I think this one is 0.6. It's something like, and I've worked backwards here to find this, it's some ridiculous number like 0.67. So I'm going to go with that, 0.67. So 5 lots of 0.67 is 3.35-ish. Seems really silly, but that's what it is. This next one, it's got a class width of 5 and a height of 1.2. So 5 lots of 1.2 is 6. This one is 5 lots of 0.6, so that's 3. And this one is 15 lots of 0.4, so that's 6. Now I know this doesn't work out at a whole number of trees, but for some reason that's what it is. It's possible that this is a histogram where the numbers have been scaled down a little bit. In other words, the frequency is not exactly equal to frequency density times class width. You do get histograms like that a bit later on. But anyway, let's just use these numbers. So we are, if I add up the number of trees I've got there, 5 plus 3.35 plus 6 plus 3 plus 6. Okay, I get 23.35. Divide that by 2. So the median is 11.67 Now, is that in here, in the first bar? No. If we include the next one, is it in there? No. That'll take us up to the 8th, but it will be in the next one. Okay, so if I take away 8.35 from that, it gives me 3.325. It is that many into the 6 in that middle bar. So it's just over halfway through that middle bar. Whoops. So it is that fraction out of 6 times a class width of 5. And don't forget to add on to the lower bound, which in this case is 155. So that's 157.77 I got. I know the book's slightly different, but yeah, so the book gave an answer of 0.81, so we're pretty close there. I mean, I worked back from that 0.81 to give me this weird value of frequency density here, and yeah, I'm not sure how you're meant to predict what that is. Anyway, we now have two medians. Which one is bigger? Woodland B is bigger, so we can say trees in Woodland B are higher or have a higher median. Therefore, they are taller on average. And let's just go with the range because it'll be easier in this case. So the range here is 40 for woodland B, and for woodland A it is 50. So woodland A has a higher range. Okay, we can compare skew as well. This one is, there's more values to the right of the median, so this one would have negative skew, excuse me. This one, again, slightly more values to the right, I'd say. So negative skew as well, so really nothing really to compare there in terms of skew.